بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. Inshallah, in this session we will cover chapter 21, which is going to be about concurrency control. If you remember in the previous chapter, chapter 20, we were talking about transaction processing. We talked about transactions, the importance of transaction, what they are made of, what they consist of. They consist of different operations. We talked about read and write. Then we covered how they can be conflict, how they can be also saved in the database and then saved to the storage. We talked about why concurrency control is needed, but we didn't talk about one of the strategies. So today, inshallah, we will cover one of the strategy that can be applied, which is the two-phase lock strategy that can be applied to prevent conflicting. What also covered, we covered the status and how they can be saved, how they can be rolled back or recovered. We talked about the log, how they can be saved in the storage, and etc. So we talked about a couple of things, and then we ended up by talking about conflicting serializability and conflicting equivalent, and we saw the difference between them even in the lab. One of the things that we're also going to talk about today as well is conflict serializability. We know that we have two types of schedules, either serial or non-serial, and if it is non-serial, we have also two categories: equivalent to serial, serializable, or not equivalent to serial, which is going to be not serializable. And we explained that in different scenarios previous week. Conflicting serializability or conflicting serializable, one of the things that I want to emphasize on, it's a schedule S is said to be conflict serializable. So first of all, it is not serial. And then we can call it serializable if it is conflict, or sorry, it's conflict equivalent to some serial schedule S. So I'm having some serial schedule S and it's equivalent to them. Okay, so let's see that together in our session today. So today we're going to talk about concurrency control. How can we address the conflicts we have in our data based transactions? So the purpose of concurrency control, again, you might already know that. So to enforce isolation, I do want to separate the conflict operation, or I want to have them as serial, because we already know that serial always are correct. If I'm just having one transaction starts and then ends, another one starts and then ends, that's going to be true because it's serial. If I'm having as not serial, and then I'll check if it is serializable, so I'll take it. If it is not serializable, so it might resolve with different answers, which is not correct. So to preserve the database consistency through consistency preserving execution of transactions, to resolve read-write and write-write conflicts, which we already covered if you remember in the previous lecture. Example, in construct execution environment, if T1 conflicts with T2 over data item A, so I'm having two transactions, T1 and T2, and there is a conflict because they are, one of them might be read and the other is write on the same data item A, then the existing concurrency control decides if T1 or T2 should get the A, and if the other transaction is rolled back or waits. Lock is a variable associated with a data item that describes the status of the item with respect to possible operations that can be applied to it. So now, when I'm talking about concurrency control, just keep always in your mind, there is a variable called lock that is associated with every variable that we have, with every data item that we have. So for example, if I'm having the data item A, then I'm having a lock variable associated to it in case if it is locked or unlocked. So it will be just like a variable, and we will know about it more in coming slide. So one lock for each data item. So every data item that we have, there will be a lock for it. It will let us know if that variable or that data item A or X or Y or etc., if it is locked or unlocked. Locking data items doesn't ensure serializability in some modes, such as binary and read-write lock, which we will talk about it in a minute, whereas it enforces serializability in certain protocols, such as two-phase lock-in, which is the main thing that we will reach to it at the end of this session. So today, what we will going to talk about, first of all, we will cover three concepts of locking. The first one is binary, then the share, exclusive, and lastly conversion. And after we finished with all of them, we will see how can we apply these concepts to have a lock-in, let's say, strategy or technique, or control concurrency technique, let's say. And that's going to be the two-phase locking, okay? At the end, we will have a problem that's going to be arises from the two-phase locking, which is going to be called the deadlock issue, which we will discuss it at the end of this slide. So three things that we talk. First of all, the three concepts, and then two-phase locking, and lastly, the deadlock problem. So here summarizes some of the three concepts that we would talk about. It says a database, let me grab the laser, a database system occupied with the lock-based protocol use a mechanism by which any transaction cannot read or write data until it acquires an appropriate lock on it. So without the correct lock, you won't get access. So now it's going to be a mandatory rather than an optional. Now, if you want to get or to read or to write an item, you have to decide which lock you will give. Other than that, you cannot get the item. We will see in a minute how that works. Types of lock, algorithm, and protocols. So these are the three concepts: binary lock, shared exclusive lock, and convergent lock. At the end, we will have the shrinking growing lock, which is the two-phase locking. That's going to merge some of these concepts into it. Rather than reading these definitions now, they will just confuse you a bit before understanding the concept behind them. So what we will do, we will go to the next slide. We understand, first of all, the binary lock concept, the shared exclusive lock concept, the convergent lock concept, and then when you get back to this slide, you will understand these for sure. So what we will cover, it will be the same as these definitions. First of all, let's start with the binary lock. It's a concept of locking that can be used in two-phase locking techniques, but it's rare. It's not that much common, let's say. Locking is an appropriate which secures permissions to read, permission to write data item for a transaction. Example, I told you about, if you remember, the lock variable that is associated with every data item that we have, right? So we have a lock associated with every data item. If it is locked, that means the data item is closed. No one can use it in the moment because there is another user is using it now. Okay, that's the meaning of it. So data item X is locked on behalf of the requesting transaction value of 1. So if, for example, if you're looking for the data item X, and if you get the variable lock X, if it equals to 1, that means there is another transaction. It's using the X data item in the moment, and you cannot use it till the data item lock X get back to 0. So now if it is 1, if you just execute this lock X and you were given 1, so you have to wait. And there will be a queue for all transactions that looking for the same data item, because there is someone is using it right now. Whenever it's finished, it will return the lock X rather than 1, it will be 0. So in this case, it's available and you can go and change it to 1 and it will be reserved for you. This is the scenario. Unlocking, it's an operation which removes these permissions from the data item. So in order to remove, you will just unlock X. And in this case, if you just get the lock X, it will equal to 0. So you have lock and unlock. Data item X is made available to all other transactions and it will be value of 0. Okay. The problem with the binary lock, if you want either to read or write, you have to lock the data item. So for example, if transaction 1 wants to read X, so first you have to lock X. You have to lock it. And no one else can use it. Even though you won't do anything with it, you're just going to read and leave it. So you have to lock the X and then read it and then unlock it. So it's quite strict. And if you want, of course, to write on X, you have to lock it, write on it, and then unlock it. So let's read the second slide. It says waiting queue. It's the transactions queue that is designed to handle transactions waiting for the status of locked data item to change to unlocked. And this is what I've been told you about, or I've been telling you about. If you remember here, I told you there will be a queue. So if you get to the same data item and it's already reserved, it's already locked by another transaction, so you will be waiting in the queue. And there will be other transactions that waiting for the same data item as you. And there will be first comes, first serves, okay? Disadvantage of binary lock, too restrictive, as it doesn't allow multiple transactions to work on the same data item at the same time. So as you just see, or so, you cannot have the same accessing on the data item from different users. Now, even if you want to read, you have to lock the variable. They will be reserved for you, and then you just unlock it. The other one will come and unlock and etc. So it will be quite, or it will take a long time, especially if you have a big database and a big number of users accessing simultaneously at the same time. Also in binary, we have this table, and that table is managed by lock manager. The lock manager manages locks on data items. So there is something that called lock manager will manage who is accessing this data item first. For example, if there is high number of transactions want to access the data item X, so the lock manager will arrange that for us. Okay, you come first, now you start. Okay, you all wait in the queue list. Okay, the other one finished, now you can grab the other transaction to start processing, and etc. So that's going to be the responsibility of the lock manager. The lock table, lock manager uses it to store the identifier of. So the lock manager has its own table to arrange everything. The lock table consists of transaction locking a data item. So here you can see the table. It starts with the transaction ID. Who is the transaction that's locking the data item now? And the data item ID. What's the data item that you want to change or you want to read or write? What's the lock mode? Okay, so the transaction 1 wants to access the data item X1 and wants to read. Okay, and these records are saved as a linked list. So in order to see the other one in the queue, that will be a pointer here, and the pointer will reference or will point to the other transaction that in the waiting list. Okay, so if you have 10 transactions, for example, there will be 10 records and there will be the pointers in the last column. They will just point to each other inside the storage. Okay. The database requires that all transactions should be well formed. This is one of the requirements to apply the binary technique or the binary concept locking. So the things that I will say here, it's same as these things already mentioned here. So both are correct. If we read these here, so it must look, how can we say the data or the database or the transaction is well formed? It must apply these 3 points, or for more details, it will be 4 points here. It must lock the data item before it reads or writes to it. So before you read or write, I told you, you must lock it. You cannot go and read or write directly. You have to lock. It must not lock an already locked data item. That it wouldn't make sense. So if it is already locked, you don't need to lock it again. And it must not unlock a free available data item. Okay, it must only unlock the transaction which has locked. Okay, so if you already lock an item, after you finish with it, you must unlock it. And you cannot unlock an item which is already unlocked. That wouldn't make sense. A transaction T must also issue the operation lock item before any read item or write item. So just focus on here. So this is what I'm going to underline now. It's lock item, and here read item and write item. These are operations. These two are operations. And here in the lock item, it's the binary, for example, in this case, it's the binary locking strategy or concept. Make sure to not be confused about it, especially in exam, while you are in a hurry and etc. You will just miss reading it. Just focus always if it is lock item or read or write item. Okay. Operations are performed in T, and this is the same as the one that we discussed in the previous slide. Let me grab the laser again. Transaction T must issue the operation on lock item after all read item and write item operations are completed in T. So you cannot just put unlock item before you finished all operations. So whenever you finished all operations, you put the unlock item. Transaction T will not issue a lock item operation if it already holds the lock on item X. So you cannot lock the item which is already locked. And lastly, you cannot unlock an item which is already unlocked. No two transactions can access the same item concurrently. And this is the summary of binary locking. An example of how binary locking can work. See how the lock operations in the binary locking technique works. So if lock X equals 0, that means it's available, right? It's available and the item X is unlocked. So what we will do, we will change the variable of lock X to be, rather than 0, to be 1. And now it's locked. What if the lock X equal 1? In this case, you will wait until it's empty. So wait until lock X equal 1, and the lock manager, if you remember the lock manager, the one here which we talked about, the one is responsible of managing and arranging the accessing of data items in our database, will resolve that for me. And when the item awake again, or let's say when the item get back to 0 and it's available again, so it will just wake you up, and then you will go and change the lock from 0 to 1 to be locked for you, right? So whenever you wait and whenever it's returned back to 0, you just go back to B. You will go back to B, and then you will ask, or you will go through the conditions again, if and else. How to unlock operation. So you already lock the operation. How to unlock it? you just change the lock X to be 0. That's it. Because it will be 1. If any transaction are waiting, then wake up one of the waiting the transaction. So after you change it to 0, you will check the queue, or the manager will check the queue for you. Okay, there is other transaction are waiting, just then wake them up, let them know that the variable X is already available, and let them take it and reserve it. Okay, so these are 2 cases, lock and unlock. Now we go to another concept. It's it's named shared exclusive or read write. Okay, shared and exclusive or read write. The first mode, so there are 2 modes: shared, which is the same as read, and we have exclusive, which is the same as write. We know what shared means. Shared means something that different things can share at the same time. So reading and this concept, what says or what states, reading won't harm anyone. So if you read the same data item, different transaction reading the same data item won't affect the data item. Why should I lock it even if I want to just read? If all of them going to read it, let them read it together. And when one of them wants to write, just one of them, you can lock it in this case. So we have what we call shared lock. More than one transaction can apply shared lock on X for reading its value, but no write lock can be applied on X by any other transaction. So if I just having transaction 1 wants to read the item X, it will execute the shared lock X, and then I'm having another transaction wants to read again, it will also raises the shared lock statement. So I'm having 2 shared lock to the item X, that's fine. How can I write on it? When I'm making sure that there is no shared lock on it. For example, let me just throw a simple thing for you. So can I write here? Yeah, good. So for example, I'm having this schedule, T1, T2, and T3, for example. So here I just want to read. So read share, which is S, okay? Read and S stands for share X. And also at the same time, T2 starts read shared X. If T3 wants to exclusive write, so for example, write X, it will wait till both T1 and T2 unlock the shared reading. So if both of them, for example, let's say T2 finished, so it will just read, unlock X. Still, T3 cannot execute because there is someone or there's a transaction is reading in the moment. And then when T3 or T1, sorry, finished, unlock the X item, now T3 can start. So all the time it's been waiting till both of them finished reading. So when they both finished reading, now it can execute and write. So now it will be in the exclusive mode, the X data item. So the X data item will be in the exclusive mode, and no one or no other transactions can read till T3 unlock X. When X is unlocked, now other transaction can start reading again. Okay. So we can see the matrix down there. If both transactions read, then yes. If one transaction read and the other write, no. Write and read, no. And write and write, of course, no. So whenever there is a transaction wants to read, there will be no sharing. Okay, that will be exclusive. If both of them read, that will be shared. Okay. The two-phase, again, that can be used in two-phase lock-in technique, which we'll talk about later. When we use the shared exclusive lock schema, the system must enforce the following rules. Here's the rules that we must enforce. A transaction T must issue the operation read lock. Again, this is read lock, and that is read item. So there is a difference. Read lock, it's just you are looking the item. You are reserving the item. You haven't done any operation to it. Read item is the operation. Okay, so read lock or write lock before any read item operation is performed in T. So before you read an item, you have to start by read lock or write lock. Okay. A transaction T must issue the operation write lock before any write item operation is performed in T. And you might notice something here. So write lock before write item X and read lock or write lock before read an item, which means if you want to just write, you have to use the write lock, okay, to get access to write item or to operate the operation write item. But if you want to read an item, you can either read lock or write lock, okay? So with the write lock, you have the right to read as well. If you just write lock it, you have the possible, or you can read an item, even though you just use the write lock, okay? Or you can use write or read lock to read an item. A transaction T must issue the operation unlock after all read item and write item X operations are completed in T. So you cannot unlock an item before you finished all the operations on it. Okay. Okay. Here is the scenarios that we can face if we are using the shared exclusive. Here's the read operation, okay? So if lock X equal unlocked, so it's available, what you will start by doing, you will just read lock the item X. So now the lock X will be assigned as read locked. Okay, so there is a transaction, which means that there is a transaction is reading from it right now. Okay, and we will increase the number of how many transaction is reading in the moment. I told you we can, if we have 5 transactions, all of them wants to read, or all of them want to read the data item, that's doable because all of them will read and then will execute. And after that, after they execute the reading, they will leave and unlock the item. So I want to keep track of how many transaction is reading a data item concurrently or simultaneously. And that will be the end, okay? What if you check the lock item and you want to read, and you found that the lock item in the read locked state, so there is another item already, or there is another item is reading now, the X data item. So what you will do, actually, you will just increase the number of reads because you will read with the other transaction, okay? So the transaction that issues the reading lock knows for sure there is another transaction is reading. So you just increase the number of how many transaction is reading. So if it is 4 transactions reading simultaneously X in the moment. So now it will be 5. Okay. But what if, okay, if it is else begin wait. So here else, so we start with F, else F, and then else. With else, if it is not read locked, not unlock, it will be what? It will be write lock. And we know that with write lock, only one transaction can access the data item. So with the write lock, you will just wait till it becomes back to unlock. Because whenever it finished writing, it will return it back to be unlocked again. So it will wait, and the lock manager, which we already talked about, that responsible to manage and arranging the transactions, will wakes up the transaction again. So whenever it finished and come back or got back to unlocked, you will go back to B, and again you will ask the same question. If it is unlocked, you make sure it's available, and then you will change the state to be read locked, and you will increase the number by 1. What if you want to write? If you want to write, you will check the lock X. If it is unlocked, that means it's available and you can write on it. So you will change the status or change the lock to be write locked. Else means that there is other items reading. If there is other item reading, we have to wait. So if you have to wait, so you have to wait till the data item get back as unlocked. And then when the lock item been assigned to unlocked, you will just go back, check it. If it is unlocked, you will change it to read, or write locked. And the last thing that we have, the unlock status or the unlock operations. So if lock X equal write locked, then you can just start by unlocking. So if you finished with the write locked, you can just unlock it. You will assign unlocked, and you will make sure there is no other transaction is waiting. Okay, what we call it, the lock manager will go back and check if all the transactions, no transactions waiting. If there's some transactions are waiting, then it will check who is going to be the first to execute. Else if the transaction was read locked, so what you will do, you will check first if it is minus, or if you will check first if it is read locked. If it is read locked, you will decrease the number of records by 1, because it might be one of the transactions that, let's assume that we have 5 transactions reading. If this transaction wants to leave, so that it will just execute unlock operation, right? Unlock operation, what it will do, it will just minimize the number of reads by 1. So now rather than 5 transactions reading, there are 4 transactions reading, and it will be assigned back to it. If the number of reads equals 1 or 0 equals 0, then we will just make it as unlocked back again. Okay, because we know if there is no transaction is reading, it will be unlocked. It will not stay in the read locked status or state. The lock table for shared exclusive lock. We have another lock manager for the shared exclusive. Here it will keep a track of the data item ID. So here's, for example, I'm looking or I'm accessing the data item X or Y or Z. What's the lock type? Is it read lock? Is it write lock? And then the number of reads. In case if it is write lock, it will be 1. Okay. If it is read lock, it considered how many, or depends on how many transaction is reading. So for example, if there is 5 transactions reading, you will just put 5. And lock in transactions, it will be the transactions that now is reading, how their names, let's say transaction 1, transaction 2, 3, 4, and etc. So the transactions that are reading now, or the one transaction that is writing. Okay, in case the lock was write lock. And lastly, it's going to be a pointer that just point to the next data item locked. It can be used as a linked list. The last concept that we want to talk about as well today is lock conversion. And it simply says you can upgrade a lock or you can downgrade a lock. If you have a reading lock, okay, so see here it says existing read lock to write lock. So if you want to upgrade, we know that read, it have less privilege considered to write, right? So if you want to read and you want to upgrade to write, that's called lock upgrade. So now from reading lock, you will upgrade the transaction to have the write lock. But there is a condition. If TI has a read lock and TJ has no read lock, then convert lock X to write X, which means there is only that transaction who is reading in the moment, okay? So TI here has a read lock on X and TJ has no read lock on X. So TJ doesn't read now, but TI just reads. So only TI is reading X. No other transaction is reading, and TI wants to write on it now, so it can upgrade itself to be in the right lock. We call this upgrading, okay? Else, if TJ and TI reading the same data item X, so TI must wait till TJ finished. If TJ finished, now TI can upgrade itself, or it can be upgraded. Look, downgrading, it's the opposite. You just downgrade the transaction TI from write lock to read lock. So to convert write lock to read lock, there is no conditions here, because if you are in the read lock, there is no one is sharing it with you. You are having the data item alone. And rather than leave or unlock, you want to change to read. That's fine. You can change from write lock to read lock. And at the same time, if there is any transactions wants just to read, they will be allowed to access with you. Now we want to talk about the two-phase locking technique. It's one of the techniques that used to solve conflict in transaction, and it's called concurrency control technique. One of these techniques is two-phase locking, or you might see it also as, it's written as 2PL, two-phase locking, okay? So we have two phases from the name. The first phase is growing and the other one is shrinking. So with saying growing, I mean that, first of all, with this technique, you will start with growing, and the growing refers to here as going and locking more data item. So you will start lock items, lock items, lock items. You will reserve a lot of items. And then when you start to unlock one item, you cannot lock items again, okay? So you lock item X, you lock item Y, item Z. And if you unlock item Z, from this moment on, you cannot lock any data items anymore. You just have the unlocking option available for you. So if you want to lock more items, you keep waiting. Do not unlock any items till you are sure that you don't need to unlock more. Then you start unlocking or release. So because of that, it's called locking and, oh, sorry, growing and shrinking. So let me show you. So this is, let's say, the timeline. And here's how many locking items you've locked, okay? So let's say the green one, here it's the transaction number 1. So just put green T1. It starts by looking on item X, then Z, then W, and that's the phase of growing. Okay, this is the phase of growing. And when it starts to unlock, let's say it starts by unlocking W, so that's going to be the shrinking. So W, now you, how many locks items already there? 2 items. You unlock Z, one item is remaining locked, and then you unlock X. You get back to the starting point. Another transaction, let's say with blue, transaction 2 starts by locking items, and then again it will get back to shrinking phase. It cannot start by looking, for example, let me just show you something. You cannot, with the 2-phase looking, start by lock X, lock Y, and then unlock Y, and then lock Z, unlock W. You cannot do that. You just have one way to go and one way to get back. This is called growing, and this is shrinking. Okay. So looking growing phase, a transaction applies look, read look, or write look on a desired data items one at a time. This phase can include upgrade phase. You can upgrade. So for example, if you have an item that look for reading, you can just upgrade it to unlock, or sorry, look for writing. Unlocking shrinking, it's the transaction. Let me read the definition with you. Transaction unlocks, it's locked data items one at a time. So you will unlock them one at a time. This phase is called downgrade phase. And here's the requirement which I just showed you. For a transaction, these 2 phases must be mutually exclusively, that is, during locking phase, or sorry, during locking phase, unlocking phase must not start. You cannot unlock while you are looking. You just keep locking until you finished, and then you can unlock. And during a locking phase must not begin. If you start by just unlocking one, you cannot keep looking. No, now the only option you have is to unlock items. Advantages is enforces serializability. With this techniques, you will have always schedules serializable. Okay, so even though if they are not serial, they will be serializable. Okay. Disadvantage, limits amount of concurrency. So a transaction T cannot release X because it needs to lock Y. Again, if item, for example, T1 here, lock item X, and wants to do a lot of things with the item X. Let's say, for example, read X and etc. And still it wants to, now it wants to unlock it because it doesn't need X anymore. So I just locked X and I do want to unlock it, but I cannot start unlocking because if I unlocked X, I cannot lock any data item more. Okay. لو أنا الآن سويت لوك للإكس هذا الطريقة وسويت له unlock، هذه يو باختصار الانلوك، سويت انلوك، مستقبلا ما اقدر اسوي لوك للترانزاكشن هذه. الترانزاكشن هذه ما تقدر تحجز قيم مستقبلا اضافيه لانها سوت انلوك وبدت بعمليه الشرينكينج. فلازم قبل ما تسوي عمليه انلوك لازم تبدا تسوي لوك للفاريبل اللي انت تحتاجها. يعني راح تبدا تحجز الفاريبل واي. ليش حجزتها من بدري مع انك ما تحتاجها الحين؟ تحجزها لانك انت راح تحتاجها مستقبلا، وانت محتاج انك تسوي انلوك للواي، ما تحتاج عفوا ما تحتاج الاكس. الاكس خلصت خلاص، سويت له قراءه وخلصت منها، انت ما تحتاجه. لكن ما تقدر تسوي unlock للإكس إلا إذا اللوك للواي بدأته. فبهذه الطريقة يكون أنت بدأت لوك إكس لوك واي. الآن لو سويت لوك إكس بهذه الطريقة أو unlock للإكس، ما عاد يمديك مستقبلا إنك تسوي لوك لأي فاريبل جديد أو ديتا ايتم جديد. خلاص الشيء اللي تقدر تسويه الآن تقدر تقرا ريد ايتم للواي أو رايت ايتم، وبعدين في النهاية لما تخلص منه كل شيء راح تسوي له إيش؟ unlock y. هذه الفكرة. هذا شيء يعطلك لأنك أنت ما تحتاج الإكس بزيادة. في ترانزاكشنز أخرى تنتظر الإكس منك، لكن أنت ماسك الإكس لأنه ما تقدر تتركه. لو تركته راح تبدأ الشرينكينج فيز، وأنت ما تبغى تبدأ الشرينكينج فيز، لسه تحتاج تسوي لوك ل other variable. هذا الشيء ياخذ وقت كثير في عمليات ترانزاكشن، خصوصا إذا كان عندك عمليات كثير زي ما قلنا سابقا تكرارها. Transaction T must lock the additional item y before it needs it so it can release x. هذا الشيء اللي شرحته قبل شوي. Here we have transaction 1 and transaction 2. They are not following the rule of two-phase locking techniques. Okay, they are not following the rules, and if you just basically see it, you will know why, because you can see read lock. Okay, this is read lock, and write item, this is an operation. That must be the start of the growing, but here it's unlocked. Why? And when you start by unlocking, you can lock in the future, but you can see here it lock another item. So it is not following the two-phase locking technique. Okay, and you can see that straightforward. Even the transaction 2, the same. So here it starts by looking and then unlocking, and then it locks back again. There will be two scenarios if you want to have it as a serial. If you just assign x to be 20 with the initial values and y to be 30, you have two scenarios. Either T1 will start as a serial. So if you want to have them as a serial, not serial. If you want to have them as a serial, either T1 will start, then T2, or T2 will start and then T1. If T1 is a start, and then T2 x will be 50 and y it will be 80. If the opposite, x will be 70 and y will be 50. Both correct because both of them are serial. Okay, so T1 starts and finished, T2 starts and finished, or the opposite, both serial. Okay, and with serial always it's correct. It doesn't matter who, or it doesn't matter the numbers, because we know that serial always are correct, and the order of the execution won't be conflicting with each other. We know that y it will be locked, and then if we start with the T1, for example, y will be locked, it will be read, it will be unlocked, all of them will be finished, and then T2 will start again. So it just depends which transactions start first. Okay, what's the schedule in front of us is, if you remember, this is going to be serial or unserial. This is not serial. Okay, but is it serializable? It won't be serializable. Why? Because the answer of it, if you just solve it and you assign the initial values for x to be 30 or 20 and the y 30 as the previous one, you will have x will be 50 and y is 50, which means it's not serializable. Why it's not serializable? لما تكون serializable قلنا انها تكون تشابه بعض السيريال. طيب السيريال اللي عندي اما تكون 50 80 x 50 والواي 80 اذا بدات التي 1 والتي 2، او اما تكون 70 50 الاكس 70 والواي 50. هل هذه النوت سيريال equivalent to serial؟ لا، القيم اللي اعطتني اياها اعطتني اكس 50 وواي 50. في هذه الحاله ما اعطتني ولا واحده تشبه اما التي 1 اللي تبدا ثم التي 2 او التي 2 اللي تبدا بعدين التي 1. معناها not serializable. It's not serializable. ولانها اصلا لو تشوفونها الان ما تتبع التو فيز لوكينج اللي تكلمنا عنها قبل شوي. لاحظوا معي في التو فيز لوكينج قلنا ما نبدا عمليه الانلوك اللي احنا متاكدين. لاحظ هنا في انلوك وبعدها بدا لوك، ونفس الشيء عندي هنا عمليه لوك وبعدها عندي عمليه انلوك وبعدها بدا عمليه لوك جديده. هذا الشيء ينافي او يخالف نظام التو فيز لوكينج تكنيكس، عشان كذا اصلا اعطاني قيمه لا هي من الريزلت الاولى او الريزلت الثانيه. قلنا نسميه serializable اذا كان يعطيني، موجوده عندي بالسلايد الماضي شرحناها سابقا. A schedule is said to be conflict serializable if its conflict equivalent to some serialists. هو الان ما يشابه ولا واحده من اللي ذكرناها. طيب لو طبقنا عليه يا شباب التو فيز لوكينج تكنيكس، هل ممكن يكون serializable؟ احنا قلنا انه لو طبقنا على اي شغله two phase looking techniques it will be guaranteed to be serializable. جهزت عرض اضافي 5 سلايدات يعطينا الصوره واضحه. هذه نفس الصوره اللي قبل شوي شفناها، نفس الفكره اللي شفناها يعني في السلايد الماضي شفناها. Is it serial or non-serial? It's not serial. We know that. It's serializable or not serializable? We know it's not serializable. It will give me different answers, and we saw that already. So these are the answers: x50 and y50, which is not same as the serial results that we got. So apply the two-phase locking, which is one of the concurrency control techniques. What if we put the right lock before, okay, and the right lock before the unlock? So now if we have another transaction، لو كان عندنا transaction جديدة وكانت الرايت لوك هذه بالأعلى، معناه بدأ عملية الانلوكينج دائما بعد ما أتأكد إنه ما في عمليات لوكينج جديدة. خلينا نجرب ونشوف واحد يعني يشوف الترانزاكشن بعد ما تغيرت عليها التغييرات هذه، أو كان عندي ترانزاكشن بالتغييرات الجديدة هذه، كيف راح تعطيني serializability ولا ما راح تعطيني serializability؟ طب نشوف، نعتبر انه هذه ترانزاكشن جديده اللي هي على اليمين الان عندي مختلفه عن الموجوده على اليسار. الاختلاف الوحيد اني رفعت الرايت لوك اللي موجوده زي ما تشوفونها بالاسهم الى قبل الانلوك، ورفعت الرايت لوك من جهه التي 2 الى قبل الانلوك، فصار عندي ريد لوك رايت لوك، وبعدين بديت عمليه الشرينكينج. طبعا هاي تعتبر عمليه ايش؟ جروينج اللي بالاحمر. بديت عمليه شرينكينج، انلوك وتخلصت من اللوك وما عندي عمليه لوك بعدها. نفس الكلام بالتي 2، صار عندي لوك ولوك، هذه عمليه جروينج، بعدين صار عندي عمليه شرينكينج. طيب الشكل اللي امامي الان هو الشكل اللي قبل شوي احنا شفناه. طيب سيريال ولا نوت سيريال؟ نوت سيريال. تشوفونه قدامي واضح نوت سيريال. لكن الان هل هو سيريلايزبل ولا نوت سيريلايزبل؟ لو تجون وتاخذون الارقام اللي كانت عندنا موجوده اللي هي الاكس 20 والواي 30، راح يعطيكم نفس الارقام اللي كان يعطيني اياها مين؟ انا اجي اوريها لكم. نفس الارقام اللي كان يعطيني اياها للسيريال، راح يعطيك اما الاكس تساوي 50 والواي 80، او الاكس تساوي 70 والواي 50. معناه equivalent to serial. نرجع، قلنا الان اصبحت serializable. بمعنى ليش serializable؟ لان لو اعطينا الاكس 20 والواي 30 راح يعطيني نفس القيم اللي تعطيني اياهم السيريال. مو بس كذا، اقدر اخليها بالترتيب هذا. ليش تقدر تخليها بالترتيب هذا؟ لاحظوا معي شغله الان، لما طبقنا عليها عمليه او طبقنا عليها التو فيز لوكينج، شوف ايش صاير معي. اول شيء بدأت بعمليه اللوك واي، ريد ايتم واي، لوك اكس، وسويت انلوك لمين؟ للواي. لاحظوا عمليه الترانزاكشن 2 الان، ترانزاكشن 2 ما تقدر تبدا. ليش ما تقدر تبدا؟ لانه انت سويت رايت لوك للاكس، انت قفلت الاكس بالرايت لوك، وقلنا في عمليه الرايت لوك ما احد يقدر يدخل على العنصر الا العنصر اللي يكتب عليه، يعني في عمليه الكتابه ما احد يقدر يدخل الا العنصر واحد فقط. موضوع مو شيرد، الموضوع اكسكلوسيف، حصري فقط للتي 1. التي 2 ما يقدر ولا اي عنصر اخر يقدر. التي 2 يبغى يسوي لوك بنوع ريد الى الاكس، ما يقدر يدخل، لازم ينتظر الرايت بلوك هذه تقفل. طب الرايت لوك اكس متى تنتهي؟ لاحظوا معي، تنتهي هنا، تنتهي هنا. ايش اللي بيصير؟ صح ان الان نم سيريال امامك، لكن اللي راح يصير ان التي 1 كلها راح تنعرض. لما تخلص التي 1 راح يسوي انلوك للاكس، راح يفتح مجال للتي 2 تبدا. كأن اللي سواه الشيء اللي موجود عندك على اليسار او على اليمين، بدأ بالتي 1 كامل ثم بدأ بالتي 2 كامل. عشان كذا حطيت لك علامة الايكوال، لكن هي بالاصل امامك بهذه الطريقة اللي موجودة على اليسار، لكن على اليمين هذا الشيء الواقعي اللي قاعد يصير، كأنها صارت سيريال. عشان كذا سميناها ايش؟ serializable. طبعا قلنا لو طبقنا عليها الاكس والواي اللي كانت تعطينا اياها السيريال، لما جربنا تي 1 وتي 2 سيريال سابقا، راح يعطيك اياها الجديده لانها الان تساوي او سيريلايزبل بالاصح بهذا الشكل الجديد لها. راح ارفع لكم العرض هذا مجرد ايش؟ يكون عرض توضيحي لك يساعدك في توصيل الفكره. انتهينا من هذه. دقيقتين واكمل الشرح. طيب نكمل، توقفنا هنا. نتكلم على الترانزاكشن السابقه اللي شفناها قبل شوي، اللي كانت هذه، بس بعد ما طبق عليها موضوع التو فيز لوكينج، كيف راح يكون شكلها لو غيرناها او عدلنا عليها موضوع الشرينكينج والجروينج. فafter you, let me grab the pen again, after we moved, the right look of that will be applying the two-phase locking technique. Again, if we move, the right look of that will be just also applying the two-phase locking technique. And here we can see it ordered for us, the same one as the one we've just seen. And just put them next to each other so you can see the difference. The one on the right after applying the two-phase locking techniques, and the one on the left that doesn't follow the two-phase locking protocol. what we've seen, it's called 2PL, two-phase locking, and it's also named as a basic. Okay, so it's basic transaction locks data item incrementally. This may cause deadlock, which is dealt with. And this is one of the issues that we want to address in this session. Deadlock problem, deadlock occurs when each transaction T in a set of 2 or more transactions is waiting for some item that is locked by some other transaction T in the set. عندك مجموعة من الترانزاكشن ينتظرون ترانزاكشن معينة تعطيهم الفرصة انهم يدخلون العنصر هذا. العنصر هذا اللي ماسكه الترانزاكشن الاول اللي نفترض ماسكه مسوي عليه بلوك او مسوي عليه لوك سوري وما ترك لهم. ليش ما تركه؟ لانه منتظر مثلا ترانزاكشن 2 تترك عنصر اخر هو يحتاجه وهو ما يبغى يبدا مرحله الشرينكينج وبعدين ما يقدر يرجع. ونفس الشيء التي 2 منتظر التي 1 يعطيه العنصر لكن التي 1 ما يقدر يعطيه زي ما قلنا لانه لو سوى انلوك راح يبدا مرحله شرينكينج. تي 2 ما راح يبدا او ما راح يسوي ريليس او ما راح يفك العنصر اللي معه. ليش؟ لانه ما انتهى من العمليات اللي عنده. هذا الشيء نسميه ديد لوك. الموضوع ما راح يخلص. التو ترانزاكشن راح تظل مستمره في دائره لا تنتهي. ففي مجموعه حلول راح نتطرق الى حلين مع بعض تكمله للمشكله. Hence each transaction in the set is in a waiting queue, waiting for one of the other transactions in the set to release the lock on an item. But because the other transaction is also waiting, it will never release the lock. شيء مشابه للي أمامنا الآن في المثال. Transaction 1 ماسكة الريد لوك للواي وريد ايتم. لاحظ معي الشغلة اللي قاعد تصير الآن. الواي مقفلة بريد لوك، يعني لو أنت تبغى تقرأ الواي ما في مشكلة، لكن لو تبغى تكتب على الواي ما يمديك. التي 1 ما انتهت فما تقدر تسوي عملية انلوك للواي لأن باقي تبغى تسوي عملية ايش؟ رايت لوك على الاكس. ولو سوت عملية انلوك هنا ما تقدر، لو سوت عملية انلوك بهذه الطريقة ما راح تقدر ايش؟ تسوي رايت لوك للاكس. قلنا عملية الانلوك لازم تكون عملية في يعني تابعة للشرينكينج. إذا بدينا في الشرينكينج ما نقدر نسوي لوكينج جديد. فاللي قاعد يصير انها قاعده تنتظر ايش؟ هي الان تبغى تسوي رايت لوك للاكس. اذا سوت رايت لوك للاكس بعدها راح تسوي انلوك لمين؟ للواي. خلاص بعدها تقدر تبدا تسوي عمليه شرينك ما في مشكله لان اخذت الاكس اللي تبي. لكن المشكله وين؟ ان عندنا في التي 2 ريد لوك، يعني التي 2 بدات عمليه قراءه للاكس وقلنا عمليه الكتابه ما يصلح ان تتشارك مع القراءة، لازم يتم الكتابة يعني بترانزاكشن منفرد. فالآن هو ينتظر مين؟ ينتظر التي 2 تسوي انلوك للاكس عشان يكتب هو على الاكس، لكن التي 2 بنفس الوقت قاعدة تبغى تكتب على الواي. تشوفون بهذه الطريقة تبي تكتب على الواي ومو قادر يكتب على الواي. ليش؟ لأن الواي حاجزة التي 1 هنا. وهذا الشيء الآن صار عندي عملية لا تنتهي، كل واحد ينتظر الثاني إلى ما يخلص وبنفس الوقت ما حد بيخلص لأنه ما حد قادر يسوي unlock. أول طريقة لحل المشكلة نسميها deadlock prevention. A transaction locks all data items it refers to before it begins execution. يعني لما تجي T1 أول ما تبدأ لا تبدأ T1 إلا وهي حاجزة كل اللوكس. يعني ما يصلح أنها تبدأ بريد لوك بعدين ريد ايتم، لا تبدأ بريد لوك رايت لوك، تبدأ بكل اللوكس اللي موجودة. إذا في أحد الفاريبل ما تقدر أو في أحد الداتا ايتم ما تقدر تسوي عليه لوك من بدري ما تبدأ الترانزاكشن أبدا. تمام؟ يعني قبل ما تبدأ الترانزاكشن يشيك إذا يقدر يسوي لوك للواي، يسوي لوك للإكس، يسوي لوك للزي مثلا. إذا يقدر يسوي لوك لهم كلهم من الآن يبدأ الترانزاكشن. اذا في عنصر من الثلاثه هذول محجوزين، يعني لا افترض انه هو بيسوي لوك للاكس والواي والزد، الزد محجوز لكن الاكس والواي موجودين، ما يبدا، ينتظر الى ما ينفك الزد بعدين يبدا ياخذ الثلاثه مع بعض ويسوي كل الشغل اللي يبيه بعدين يترك. هذه نسميها ايش؟ الديدلوك بريفنشن. طبعا هذه تستخدم وين؟ تستخدم بالتو فيز لوكن اللي اسمها كونسرفتيف او نوعها كونسرفتيف. قلنا النوع اللي تكلمنا اول عليه سابقا ما يطبق الشيء هذا. النوع اللي تكلمنا اللي هو البيسك ما يطبق انه لازم الثلاثه العناصر اللي انت تبغاهم تحجزهم من بدري، لا ادخل واحجز، واذا خلص الترانزاكشن الثاني خذ له وقت كمل عليه. هذا البيسك. الكونسرفتيف نفس الاول لكن فكرته بس انه ايش؟ يمنعك. واضح؟ لازم تستوفي الثلاث العناصر تكون يعني available to you، تاخذهم تسوي لهم كلهم لوك، تخلص تسوي لهم كلهم اللوك. This way of locking prevents deadlock since the transaction never waits for a data item. في نوع ثاني اسمه wait أو اسمه عفوا detection for or detection and resolution. In this approach deadlocks are allowed to happen. يسمح للديدلوك انها يعني تصير، لكن the scheduler maintains a wait for graph for detecting cycle. If a cycle exists, then one transaction involved in the cycle is selected, victim, and rolled back. A waiting for graph is created using the lock table. As soon as transaction is locked, it's added to the graph. بالمختصر إذا صار عندي عملية ديدلوك يشوف عنصر من الاثنين ويحذف واحد منهم، يسوي له رول باك أو يسوي له أبورت. فلما يصير له أبورت بيطلع وبيصير له إيش؟ دخول على الداتا أو بيسوي اكسكيوشن مرة ثانية. لكن لما يطلع بيفك كل الأشياء اللي مسوي لها لوك. لما يسوي له عملية الأبورت راح يترك كل الأشياء اللي هو مسوي لها لوك ويسمح للترانزاكشن الثانية اللي كانت معاه في ديدلوك انها تبدا وتخلص. فلما يرجع راح ينتظرها تخلص وبعدين ياخذ الداتا ايتمز اللي يحتاجها بدون مشاكل. طبعا بيستخدمون فيها شغله اللي هي الويت فور جراف. ليش؟ عشان تساعدهم في عمليه الترتيب.